let's start with that. So very short presentation. Okay, my name was said. I work at Adeneo Embedded. We have offices in Germany, France, US, right? And we work on system and ecosystem. I mean embedded whole system and ecosystem. So BSP, driver, embedded, and mobile software. So all the way from the bottom of your embedded device to the top. And let's start. So quick introduction. Maybe you heard it 4 times today with different words. I'll make it quick. So what are the attributes of the Internet of Things, what it is, so Internet of what? The Internet of Things is basically a set of devices and devices that communicate, period. So if you have your PC connected to the Internet, you are doing Internet of Things, congratulations, end of the talk. A few additional elements. Usually you have associated that data acquisition, so that can be image, that can be temperature, whatever. These networks, because it's a network, can actually grow. So you will be able to add new items and can be intelligent. If you have intelligent developers, that's the condition. So I think we have here, so it's all okay. So it's quite vague but powerful. A few examples, your cars with a lot of sensors, and all these sensors are already combined and used. Your home with automatic lighting, video surveillance, etc., and even town or more are simple example of the Internet of Things. And this brings new challenges on the networking side, because you know that there is more and more devices. So that's why, for example, we need the IPv6, because that's a lot of devices and we need IP address for each of those. Energy consumption and security. So I don't know if you remember the story about the baby camera being hacked. And so a family in the United States had its baby camera hacked, and someone at the other side of the world were able to talk to the baby and move the camera. So that's a bit frightening. So that's the thing you have to consider when building Internet of Things object. So this talk will be about the Internet of Things and your consideration, the key elements of that, a bit applied to our connected clock. Qt in that picture, what tools you have in Qt, and in 4 parts, IoT devices, security, into the cloud, and last part with lights. So initially, I would need to bring the demonstration. I think for every session there was a problem. Mine was that the demonstration is so big that actually it's impossible to bring it here. But I have it at my booth, so if you have any questions or something, you can come at the booth 6, Freescale Adeneo, and we can discuss it. So let's start. So that's basically our device. That's a Freescale IMX6 board. Well, very big alarm clock, so very big success, hopefully, and additionally it's beautiful with all the wires and everything. It's based on the Yocto 1.5, and when you are doing Internet of Things, the key element, of course, is connectivity. So it can be medium, long range connectivity, so one of the mostly used is the Wi-Fi. You have support for the Wi-Fi integrated in Qt, good thing. Short range with Bluetooth low energy, NFC, RFID, etc. And good thing again here, in Qt you have support for Bluetooth and Bluetooth low energy since Qt 5.5, at least on Android. And if there is no support for your platform, that's always something that you can accommodate by re-implementing the appropriate classes inside the Qt sources. And even cables. Yeah, even in all years there is cables. Yeah, you can use cables for your connectivity. So what's the topology of an IoT system? Well, looks more or less like this. It's quite generic, so doesn't fit all the needs, but that's the idea. You have the lowest elements, the smallest one, that are the sensors. So usually here you have no CPU, just a microcontroller. One of its roles is to do data acquisition, and they are very small, like you can see. Then you have devices like our alarm clock, usually ARM architecture CPUs, may or may not have screens. You can use Qt here. broker gateway, we'll come back to that later, and finally, the cloud applications. So as you can see, if Qt is that size, it can fit in those boxes, but not here. So that's quite logical. You cannot put Qt on the sensors because it's a big circle. Of course, there is no CPU, so too low-end platforms to run that. So your consideration when using Qt on these different three elements, if you have a graphical interface, the first one, the question everyone has to ask himself at some point is Qt Quick or widgets? So that's a very vast question. It depends a lot on your platform, the application complexity, the GPU you have, and the RAM you have available. On embedded platforms, the answer is not always Qt Quick, actually. So you can see that Qt Quick has a lot of classes to manage gestures and etc. So it's perfect for embedded devices. Well, the problem is if you have a complex application, it will use a lot of memory. And if you don't have enough memory on your system, that can be a problem. That's something you can also leverage, but Qt Quick is not always the answer. Widget can and have to be considered also. And for non-graphical application, you have all the classes like networking files, database, etc. that are great, for example, to work in the cloud. And the big advantage of code sharing and good performances. So if you have, just to go back here, the same code here and here, of course you can share a lot of code to encode, decode the data and for the communication. And that's a great added value, even if on different platforms. And only considering this here, the cloud, Qt may not be always the solution if you have a heavy-duty application, like if you really want to build something like Apache. It's possible in Qt, but it's a lot more work. So Qt may be the solution. For very heavy-duty web service, not always. So that was a short hit for the embedded. And let's hit the security part. Again, I've seen that there is another talk about security, so I'll be more or less fast. The key point is no one is safe. Whatever device you are building, you cannot hide. And one example is this engine, Shodan, that lets you search for Internet of Things objects. So anything that is connected to Internet and that can be pinged, detected from the Internet can appear here and be used by some hackers or by anyone. And of course, that's one tool. Hackers don't put their tools on Google and say, let's reference my illegal thing. So that's one example, but only the top of the iceberg. So you should be careful about safety when you develop your device. So on the system side, a few things. Keep it up to date, because like maybe you know with the OpenSSH recent security breach, if you don't keep your system up to date, different failures, security failures get known, and when they are known to other people, the other people use them. So the more up to date it is, the more secure it is, at least most of the time. Remove development and unused services. If you have an SSH service running with a root password, of course that's a big security flaw. That's something you want to avoid at all costs. Include a firewall, so that's actually quite straightforward, is even on embedded device, and the usual rule is block everything that comes from the outside, and only that, if you limit yourself to that, is a great security protection. And after, to go a bit further, there is security enhancement that you can apply to your Linux, like GR security. And don't forget to seal the box. So if you have a device and you have wires that go outside, etc., it's physically possible to hack it. So you have also to make it more or less impossible to hack, or at least a bit difficult. Don't make that too easy for them. And what can you use now on the application side for your security? So there is one very great tool, which is QSSL socket, that lets you create a TCP socket with encryption, that is SSL, TSL, etc., with different versions for both. And just that in itself makes sure that the communication that you have between your device cannot be easily read and used against you. So that's QSSL socket. For that, you will need OpenSSH, but that's on Linux, and on Windows, I don't remember the name of the library, but it's quite easy to find. But apart from that, it's quite straightforward and very useful. And if you want to encrypt manually, you have SimpleCrypt, which is a very simple library made in Qt. It's a simple encrypting, but however, still powerful. Directly OpenSSH, OpenCrypto++, etc. There is a lot. Input checking. So when you receive data from the network, avoid strings when, avoid strings when possible, of course. Strings are difficult to analyze and verify that you have the right appropriate information in it. If you have integers, just manage them as integers unsigned or signed to make sure that the data that you receive is correct and cannot compromise your system. And on the screen class, you have two HTML escaped, replace, you have the regexp to verify that your input is correct. And for the database side, you have the bind value. So bind value just lets you replace some values in your query, and simply that makes sure that there is, for example, no SQL injection, which is a very common and easy attack by inserting quotes. So you have tools, you just need to check the input. And let's go into the cloud. So check a bit, Harper, what we have on the server side. So on our alarm clocks, we had some things we wanted to do. So for example, save user alarms and settings in the cloud. So if the user have different alarm clocks in the house, which is, well, let's say strange, but just for the sake of the demonstration, that's something that we may want to do. Set alarms directly from your smartphone, which means being able to access all those settings from some common interface. News, weather, and potentially intelligent wake up, depending on traffic, weather, or whatever. So if it snows, the alarm clock just doesn't ring, and you don't go to the work, because when it snows, well, personally, I don't go to work when it snows. And to accomplish that, you have different things, different terms. So you have the cloud services or dedicated server and two key elements, storage and computing. So when you try to accomplish that, if you buy a cloud services, these two terms appear and can be mixed or bought separately. The cloud storage is, of course, only data. Data that can be sometimes accessed with queries, but just data space on a hard drive on a server. So the storage will be for all user settings and alarms. And computing, so that will be traffic, weather, and analysis of the data, for example, to know when it snows or it doesn't snow. That's what we'll use. I think I wrote it after also, but yes, I wrote that after. No, never mind. And the interface to communicate with your cloud server is most of the time, HTTP and with JSON and XML. Why HTTP? It's because for your application, maybe that's not very interesting. But if you are building after a web application, like we want to use our clock on the smartphone, right? If you have HTTP interface, web interface on your service, that's very easy to integrate to create a web application and to use that transparently from your device or from your smartphone. So that's why it's a commonly used interface. And don't forget authentication, because you don't want anyone to access anyone's data, of course, but that's quite obvious. Let's see that, yes, I wrote it that. And after that, you have two different levels. You have the third-party services. So probably you don't want to create your own service for the weather forecast or for the news, I think. So for that, you have access to third-party services, so other people, company providing you this information. So weather and news will go here. And on our server, on our custom server, cloud or locally, we'll have the user preferences, the alarms, and that's it. The line after is something different. Under all servers, so you have Amazon, etc. And you have also the quite new Qt Cloud Services. So they also propose a cloud service that is for storage and or computing that lets you put code on their cloud or data that can be Python, PHP, and also Qt code. So you can directly put Qt code on their cloud services and use that for your application. And of course, it's very convenient when you are developing Qt application because you have everything you need in that context. And from our application, so from here, how do you access that these different services? How do you query that? Well, you have the very simple to use Q Network Access Manager. That is a class that lets you do HTTP queries. So get, post, put, etc. So if you want to query the weather, you simply use that class. And one example is this one. So I shortened just the name. You say get and the URL here. So probably you need more argument. And you just started a request, like reading on a file in Qt or anything. You will have a signal when the data is ready to read. And from that point, you just use QJSON document or QDOM document to extract, transform this data, and use it inside your application. And actually, I simplified a bit, because what we are doing is the application is not directly communicating with third-party services. Instead, we use our server as a gateway. So a way to access the network, which is usually what you will do, to access the third-party services, to control the access, to format the data, to make sure that if you new service change or weather service change, your devices are still able to access it the same way. And also caching to make all requests more efficient. So instead of having direct connection, you have one connection from your device to the gateway that we'll talk about a bit after. And this gateway will be the interface to all the rest of the world. And this is a picture of the cat. And, all right, now it's better. I thought I forgot that. Because I know it's the end of the day and it's difficult. Initially, I wanted to put a different picture for you guys, but no, well, forget it. A cat is perfect. And let's finish with the last part before lighting talks and then party. I hope you will be there at the party, let's say. So we have our device, and we added a lamp. So that's a Wi-Fi lamp that we want to control from our application. So Wi-Fi connected, you can control the brightness, the color, and it's actually quite simple. The thing we did is that the lamp is on a fixed IP address, and we use a UDP socket to communicate with the lamp and to change its color and everything. So this part is trivial, and because it's a simple example. When you power, and this lamp power on when the alarm rings. Now, this thing is a bit too simple, so we'll start to make it a bit more complex. One example is a remote alarm. What happens if remotely you want to make ring the alarm or make the light shine? So in that case, that's the server that has something to say. And one simple way to achieve that is to listen on some port on your device, and the server will use that port to connect and to send you a message saying, okay, light that light now. Light that light. Yeah. Of course, you don't want to accept connections from anyone, so that's why you can use the QHost info, sorry. So when you are creating a QTCP server to listen from connections from the outside, and you use listen, you can listen on a port and also on a specific host. And that's where you will want to limit that listening to the host being your server to avoid communication from the outside. Yeah, incoming connections from other devices. And again, that's a bit too simple, so here is the last step. We have all devices, so the gateway which is here, the devices that are our alarm clocks, but usually when in your home, for example, you don't have, or your devices don't know what devices are present in your house. Or if you buy a new connected coffee machine, by the way, I want one like that. There is no way the system know that the coffee machine is present here, right? So you have still all these components, but here you don't know what devices are connected. So we need something more for the flexibility. So the first tool will be the ability of the device to broadcast itself, to say, hey, I'm here. And then one great tool that is the broker approach. So the thing is, all gateway here and all device and cloud will convert into a broker with clients. And the principle is that the broker centralizes the information and the clients publish events like temperature, lights on, etc. And other clients can subscribe to these events and use them as they want. So this broker is implemented with MQTT. So you have QMQTT that represent this protocol, Mosquito, and AMQTT XMPP, sorry. The main one being MQTT. And basically with that, you can do what you want. You can add new devices will register, will publish events, others can publish to that, and for example, when your alarm rings, your coffee will start preparing in the kitchen, which is quite great. So that's all for that. Thank you for your attention. We are almost there, and enjoy the party after, or first enjoy the lightning talks. Thank you.
We maybe have time for a quick question. Anybody has a quick question? Right.
I just want to know the name of this class which is able to browse the website.
Sorry, I hear you very...
The name of the class that's able to browse the website for grabbing the weather information or something like that.
For browsing the web? The class, it's the, you mean to access HTTP data? HTTP things? So that's Q Network Access Manager.
Well, you can find Adrien during the party, maybe. He will be very happy to answer your questions.
Sure.
All right. Well, thank you, Adrien.
Thank you.